Welcome once again to another time value of money video. We're going to do problem 7 now, but I want to take you back to problem number 6 because number 7 refers to this. Number 6 problem was if we take out a traditional mortgage in the amount of $1 million with an annual interest rate of 9.6% and 15 years of payments, monthly payments, what will be the size of our monthly payments? We saw the payment amount was $10,502.67 for each of the 180 payments. Now, with that in mind, let's look at number 7. Number 7 says, consider the loan described in question number 6 above. And then it asks, immediately after we make our 60th monthly mortgage payment, what will be the principal balance remaining on the loan? Let me just show you something here very important. Okay, when we first took out this loan, the kind of with ignoring pennies, this was the cash flow date line. We got $1 million. We used it to buy a house. We probably really didn't get the $1 million at all. You know, didn't touch our hands, but effectively pretend we got it. And then at date 1, we're required to pay $10,502. At date 2, required to pay $10,502. Again, I'm ignoring the pennies. Date 3, $10,502. All the way out to date 180. We're required to pay $10,502. And just think about this for a second. If right now someone were to ask you, what was the remaining principal value of your loan? This might be, 1 minute after you got the mortgage. Well, you'd first say, well, $1 million, and then you'd realize, well, okay, $1 million, but $1 million, $1 million is just the payment of $10,502.67, I guess it was, yeah, multiplied by a PVIFA, where R was 0.008 and N was 180. Okay, so I mean, just that's true. This is just obvious and true, right? But the point here is that the remaining principal balance of a loan, the remaining principal balance of a loan is equal to always the present value of the remaining payments. The remaining principal balance of a loan is always equal to the present value of the remaining payments. And in the example I just showed you up here, it was obvious that 1 minute after you take the loan out before you make a payment, that the remaining principal balance is $1 million, and $1 million is the present value of the remaining loan payments, because that is exactly what we have over here on this side of the equation. Okay, that's obvious, so just keep that in mind. Now, with that in mind, let's answer the question. So immediately after we make our 60th payment, okay, so I'll draw another date line here for you. Okay, so in other words, at date 0, we got $1 million. At date 1, we paid $10,502. At date 2, we paid $10,502. All the way out to date 60, we paid $10,502. And now the question is saying, well, immediately after we make this payment, what's the remaining principal balance? Well, it ends up being actually quite simple. Well, what do I have remaining? I have at date 61 a $10,502 required payment. at date 62, a $10,502 required payment, all the way out to date 180, a $10,502 required payment. So if you think about it, well, it's actually quite simple. The remaining principal balance of the loan, at date 60, is just all the payments from date 61 to date 180, which of course is 120 payments. So what we're going to use is application formula 4. Again, we use it a lot. The present value of annuity equals annuity cash flow times present value interest factor for the annuity. And again, the annuity is these $10,502 payments we're making. That's an asset to someone who owns the mortgage. To us, if we're paying it, that's a liability. And again, PVIFA has an R value. The rate in decimal form is 0.008. But what's the N value? Well, N is the number of cash flows in the annuity. And since the present value of the annuity here in this example takes on the economic interpretation of the remaining principal balance at date 60, it means we've paid 60 of our required 180 payments, and we're right on time. We're looking at the value exactly at date 60, 1 moment after we make this payment. And so we're 1 period prior to date 61 is what I'm saying. So everything is just perfect for us to be able to use our very helpful interest factors. Everything lines up just right. So the N value is just 120. Right? So the answer to our question, again, is that the remaining principal balance on this loan at date 60, 1 second or 1 moment after we make the regular payment at date 60, is equal to the actual payment, the annuity cash flow, which is the payment, times this PVIFA, where again, R is 0.008 and N is 120. And what we get then when you, just to make sure you understand the payment, 10,502.67 multiplied by the PVIFA, which is 1 minus 1 over 1.008 to the 120th power, divided by 0.008. Okay, this number here, oh, by the way, that number right there, is it greater or less than 120? Well, you're right. PVIFA is always lower than its own N. The N here is 120, so it's less. And it happens to be 76.9552. Okay, and so you multiply that by the 10,502.67, and that gives us the answer, remaining principal balance, date 60, is equal to $808,235.07. So the remaining principal balance at date 60 is $808,235.07. And that is the answer to question number 7. And keep that in mind. This is an important thing to remember. And that's enough for this video. Thanks again for watching.